Hello guys, welcome back to my YouTube channel. In the last video we have seen how to model a G+6 story building in STAAD Pro software, and in this video we are going to see how to apply load on this building and how to analyze this building. So first of all, I'm going to tell you which type of load we are going to assign in this building. So here we are going to consider the following load cases like dead load, live load and seismic load. So here we are not considering the wind load, though here wind load is necessary since we are analyzing a G+6 story building, but for simplicity here we are not considering that. And also here we are not considering the weight of stair, weight of lift machine, weight of water tank. This is for only simplicity, but when we will analyze an actual building, so that time we have to consider all these loads. So under this dead load we are considering the self weight of beam and column member, and we are considering the self weight of slab. Since we are not adding any area element here, so that's why we have to consider the slab load on beam member, right? And also we are considering the self weight of wall. Under live load we are considering only the live load which is acting on the slab member, and also we are considering the seismic load as per IS 1893 code. And here we are considering the exterior wall thickness, that is 250 mm, and interior wall thickness, that is 125 mm, and unit weight of brickwork we are considering 20 kilonewton per meter cube, and unit weight of concrete we are considering 25 kilonewton per meter cube. And here also we are considering that all the wall are placed above the grid line beam, and here this beam at the interior beam, and here this boundary beam at the exterior beam. So these are all the specification for this building. So now first what we are going to do, we are going to first create the load cases. To define load cases you have to click on this general tab. Under this general tab you have to click on load and definition. So in last video under this general tab we have defined the property like section properties, and also we have defined the supports. This support 2 we have created, this is a fixed support. So now under this general tab I am clicking on this load definition tab. So here you can see there are mainly two types of loads. One is definition type of loads and second one is load cases. So here we are going to provide a definition type load, that is seismic load. So under this definition type load you can see vehicle definition, time history definition, wind definition, snow definition, reference load definition, seismic definition, pushover definition, and direct analysis definition. So here you can see if you want to apply wind load or seismic load, so that will you have to define under this definition load category. So here we are going to define seismic definition, so that's why I'm going to select this, and now I'm going to click on this add tab. Also you can assign the load from menu bar command, like you can click on this command menu, then you can go under loading, then definition load, then here you select seismic load. Here only two code is available, that is IS 1893 1984, and second one is IS 1893 2002. You can use here the latest code, I mean the version of 2016 is not available. So if you use the latest STAAD Pro version, you may get the latest code here. So click on this. Now here I'm going to select all the parameter. So you can click on this generate tab. You can click on this generate. Here you can choose the city here. Suppose this building is situated in Kolkata, so just select here Kolkata from this list. So now I have selected this, or you can change, suppose you know the directly zone factor, you can select here zone and you can choose the factor here. So now here I'm going to select the city here. So here I'm going to select Kolkata. also you can see the IS1893 code, and here in this map you can see Kolkata at zone 3. So if you know the uh, zone, you can directly select it here. Otherwise, if you don't know, you just select the city here. And here we are using, suppose ordinary in our building, suppose we are using ordinary RC frame, ordinary RC moment resisting frame. So that's why I'm selecting this, and for ordinary RC moment resisting frame, this response reaction factor value is 3. It is available in IS1893 code. In table number 7 it is given. So if you want to know details, you can see IS1893 code. But if you select here the option, automatically the value will come here. You don't need to put it manually. And importance factor, it is a residential building, so that's why it is not a important building. So that's why I am considering that importance factor here 1. And here we are considering medium soil, and it is a RC frame building. And now here damping ratio, that will be 5%. But if you write here 5, then if you click on this generate, here the damping ratio will is taking as a 5, but we have defined it is 5%. Okay, but here we are getting the value is 5. So actually it's not the correct value, it's coming. So that's why what you have to do, you have to write here 0.05. actually there is an error here. So if you write here 5, so here 0.05 value should come, but this error is in STAAD Pro software. Okay, so that's why what you will do, just manually type here, it is 0.05%, and that's all. And now add this here, and now I have add the definition load here, and now I'm going to close this. So here you can see the one definition is added here, and here only one definition type load, so that's okay. Now I'm going to add some load cases here. So just select these load cases details and click on this add. When we will define some definition type of load, so first of all we have to define the definition load first, then other load case I will add here. So here definition type load is seismic load, so that's why first I'm going to add seismic type load. So in loading type, select seismic here, and right here name the load cases, like I'm naming this SL X direction. So for seismic loading I have to define the direction. So I am considering here seismic load along X direction and along Z direction. The vertical component of seismic load I am not considering, because that is not the critical. The critical load case happened along X or Z direction. So that's why I'm only considering these two direction here. So now this seismic load is along X direction, and now again I'm going to add seismic load cases, seismic load case along Z direction. So these are the two load cases I'm considering here. Now I'm going to click on add, and now after that I'm going to add dead load, and then I'm going to add live load. Now I'm going to close this window, and here you can see under this load case details, you can see there are total 4 load cases. So first and second load cases for seismic load, third load for dead load, and fourth load case for live load. So now under dead load case, what I have to add? I have to add sail point of the member. So first what I'm going to do, I'm selecting this dead load, then I'm going to click on this add button, and here you will see this window will open, and here the first one is sail point. So under this sail point, here you can see sail point. So the sail point obviously will be in Y direction, and here the factor will be obviously 1. and here the direction, since the gravity force is acting in downward direction, so that's why here it will be -1. Now I'm going to click on this add. Now I'm going to close this. See here, the sail point load is added here, but here you can see there is a question marks. It means that this sail point haven't assigned to the member yet. Okay, so what we have to do, I have to assign this load to the member. So here the sail point will get sail point for all the member, beam, column, for all member. So that's why what I'm going to do, I'm going to select this option that is assigned to view, and then I'm going to click on this assign. Before clicking here, be sure that here the sail weight is selected or not. So now it is selected here, and now I'm going to click on this assign, and now here select yes, and now here you can see all the member is selected. It's mean the sail point is assigned to all these member. Now I'm going to add the sail point of the wall. So that's why I'm going to click on this date load, then I'm going to click on this add button, and here I'm going to select this member load. Since the sail point of the wall is a UDL type load, so that's why I'm going to select on this member load, then I'm going to select uniform force. Here we have calculated the wall load. Here the height of the wall I have considered 3 meter, and for exterior wall, if the 20 kilonewton per meter cube is the unit weight of the brickwork, then the per meter run sail point of the wall will be 15 kilonewton per meter. For 125 mm, it's mean interior wall, this load value will be 7.5 kilonewton per meter. Here we have ignored all the reduction due to door and window here. So here I'm going to write here the load magnitude. So for 250 mm wall, this value is -15 kilonewton per meter. So now I'm going to click on add, and for interior wall this value will be -7.5. then I'm going to click on add, then I'm going to close this. So now these two uniform load is added here, and here you can see there is a question marks. It's mean I haven't assigned them to any member yet. So first 15 kilonewton load will be assigned to the exterior beam. So that's what I'm going to do. First of all, what I have to do, I have to select all the beam where I want to assign this load. First I'm going to select the elevation of this model, and here I'm going to select beam from first floor to sixth floor, because at roof we are not going to provide any exterior wall. So you may provide parapet wall in roof. For that you can calculate the defined load calculation for parapet wall. So here I haven't considered any parapet wall, so that's why I'm not assigning any load of parapet wall, but you can do that. So I have selected all the beam up to 6th floor. Now I'm going to click on this view, then I'm going to select on view selected object, and here now I'm going to select the plan. Here in plan, first I'm going to assign this exterior wall load, so that's why I'm going to select all the exterior walls. So these are the all exterior walls, and here in isometric view you can see all the exterior wall I have selected. And now I'm going to select on this assign to selected beam. Now click on this assign, then yes. See here the -15 kilonewton per meter load is assigned in exterior wall. And now I'm going to the load of interior wall. So again I'm going to the top view or plan, and here I'm going to select all the interior beam here. So these are the all interior beam here, and now here you can see all interior beam I have selected. Now I'm going to select this, then I'm going to select on assign to selected beam. Now click on yes. See here all the interior wall load I have assigned here. So if you want to see what is the load value, you can turn on that. So click on here, and then select your load value, then click on apply, then okay. So here you can see uh, exterior load value is minus 15 kilonewton and interior load value is here it is very congested, but I think it's right, it's 7.5. so you can also check that here you can, so it is 7.5 kilonewton, so it's okay. Now the dead load of wall is assigned to the member. Now I have to assign the dead load of slab member. To assign self weight of slab, first of all you have to calculate what is the load magnitude. So here I have calculated the slab load. So here I have assumed the depth of the slab is 120 millimeter, and here the unit weight of the concrete, that is 25 kilonewton per meter cube. So 25 into 0.120 kilonewton per meter square, that's equal to 3 kilonewton per meter square. So we are getting the dead load on slab element, that is 3 kilonewton per meter square. And now here I am going to assign this load here. So first I am going to click on this dead load, then I am going to click on this add. So here what happened, this load is actually acting on slab. This slab load is acting on beam member. So here we haven't add any area element, right? So that's why what is happening, this slab load is transferring to the beam element. So first of all you have to know what will be the load distribution pattern. See here as per our dimension, first of all you have to know here all the slab is one way distribution or two way distribution. So as per our dimension, the ratio of longer span to shorter span is greater than is less than 2. So that's why here all the panel is a two-way load distribution. So that's why here you can see the load distribution pattern for all the panel here. So here you can see all the load distribution here is a two-way load distribution. So that thing you have to calculate first. So which panel is one-way load distribution and which panel is two-way load distribution. So here coming all the panel is two-way load distribution, and we also have calculated the load magnitude value, that is minus 3 kilonewton per meter square. Why it is minus? Because the load is acting in downward direction, so that's why it is minus. So now where I will click, so I will go to floor load, and here you can apply this floor load using the range option, or you can directly apply this load by using group. So already I have created the floor group, right? So that's why it is very easy to apply floor load when you will create the group. So now here I have created all the group, that is this is for first floor, this is for second floor. So at each floor level I have created a group. So that's why here the pressure value for first floor to roof, the pressure value will be same, that is minus 3 kilonewton. So and the direction will be global y direction. So since it is a two-way load distribution, so that's why I am not going to check this option. And now here I'm going to click on this add button. Now I'm going to select second floor, then I'm going to click on this add button, then for third floor, then for fourth floor, then this is for fifth floor, this is for sixth floor, and the final one is for roof. Now I'm going to close this. So here you can see I have added the floor load here for all floor, and here directly when you will add this load, it will be automatically assigned to the floor, because when you are adding the load, that time you are selecting the group. So that's why automatically this load will be assigned to the members. So in isometric view, here you can see the load distribution pattern. So this load actually acting on the beam element. Okay, so now in under this dead load I have assigned all the loads. First I have assigned self weight, then the self weight of the wall, then I have assigned self weight of the slab, and finally I have to assign live load here. So for live load I have to assign only the live load value. The live load actually coming actually only it is coming on slab element, and same way for live load also I have to apply some floor load. So you can do the same method here. Just select live load, then click on add, then go to floor load, and here select the groove, then here write the pressure value here. So here we have assumed that live load value is 3 kilonewton, so that's why here it is. So that the live load magnitude we have assumed that is 3 kilonewton per meter square, since this is a residential building. So you can directly write here -3, and then you can add it like that. But here I'm going to show you a different method. So I'm going to add this live load by using STAAD editor. So just I'm going to open the STAAD editor files. So to open the STAAD editor file, you have to click on the STAAD editor tool, and now here the save option is asking, so just save it. And now here first of all you have to know how to read this editor file. So here see, at the beginning of this file we have selected it is a space type structure, because here we have analyzed here we are going to analyze a 3D frame. So that's why here we have to select the space, and here the job information details is given, and now here the unit is selected meter and kilonewton. And now this joint coordinate, this command is used to define the node. To define the node, this joint coordinate command is used. Here you can see the coordinate of all node is given here, and here you can see this is the member incidence. So here all the start and end node for each member is given here, and here you can see the start group definition. So here group definition is started. So like we have name first beam x3. Here the all the member number is written here like that. All the group definition is given here, and also floor group is given here, and finally and here the material properties also is given here. So if you want to change any value here, you can do that. If you want to change the strength of concrete, you can change it here. To define the member properties, this command is used here, and here you can see the definition load is started here, and then the load type is started here. So here under the floor load, this floor load is came under the dead load option. So here you can see this is the dead load type. Under this here floor load have created. So now under this live load I want to add this floor load. So that's why what I'm going to do, I'm just going to copy this load here, and now after one enter I'm going to place it here. Okay, and here one thing you have to do, at roof the live load value will be 50% of the total load. So that's why this value will be 1.5, and others all load will be remain same, right? So only this load value will be changed. So that's why I'm changing only this value. Then I'm going to save this, and now I'm going to close this. And now check here under this live load, all this load is added here. Now we have to add seismic weight. So under this definition load, select this and click on here add. So first we have to add the self weight of the building. So just select self weight, then click on this add. So now self weight is added. Then we have to add the dead load of wall and dead load of slab. So you can use this option to add the dead load of slab, dead load of wall, all the floor load also you can add here by using this option. Otherwise you can directly add this load using editor. So how can you do that? That is the very easiest method, you can follow that. So see where the seismic weight is added here. See, so here after the definition of the seismic load, here this command is added that is the self weight, is 1. Now we have to add the uh, member load. So this member load is nothing but the wall load that I have applied under this dead load. So now I'm going to copy this load, all this load, and now I'm going to paste this load after this self weight of the member. So here I have applied the member load here, and here you have to edit this comment. What I have to do, I have to remove this direction, because since this is the seismic weight, I mean this is the mass of the building, so that's why you don't need to provide any direction here, and you have to remove the negative sign here also. And also here UNI mean uniform load, and here GY mean the global Y direction. So here direction, I am removing the direction here, and here I am removing the minus sign also. And here you have to change this weight, member weight, and now you have to save this. And now I'm closing this, and here you can see now this member load is added here. You can see the member weight is added here. So now again another load I have to add here, that is the dead load of the floor. So for dead load you have to see here, I have applied dead load here. This is how the floor load is added. So here you can see the floor load comment. So just copy this, and now just paste this load after this member load. Now here I have added, this is the floor load, and here you have to edit this. So you have to make it floor weight, and here this you have to remove this direction, and it will, the minus sign also will be removed. Now I have removed this. Okay, now save this. Now close this and check here, the floor load is added. So this is the floor dead load. Now also we have to add the live load of the building also. So if you open IS 1893 code, here you can see in table number 8 the percentage of imposed load you have to consider for seismic weight. Here given it is given here. So here our live load value up to 3 kilonewtons, so that's why we have to consider the 25% of the imposed load. So in our cases we have considered the live load value is 3 kilonewton per meter square. So that's why what we have to do, we have to add 25% of 3 kilonewton, that is 0.75 kilonewton. So what I have to do, I have to add this load here. I mean here the total load will be like 3.75. So I'm just adding this load here. So 3 kilonewton for dead load and 0.75 kilonewton for live load. So it will come like this. Or in case of roof, we will not consider any live load. So here we will not add 3 kilonewton here. So now just click on save, and now all the seismic weight we have defined here. Now I have to add seismic load. I already have created the load cases. So the first load case is seismic load at x direction. So select this, then click on add. Then in this window we will click on this seismic load, and here we have to select the direction. So since we want to add seismic load only in two directions, that is x direction and z direction, so under x direction load case we are going to select here direction x direction, and factor will be 1 here, and then close. Then under seismic load at z direction I will add the seismic loads along z direction, then click on add. So here we are not considering the negative direction, because you know, when I will create the load combination, So automatically the plus minus detection load will be generated, so that's why I'm not considering the negative detection load. So now I have to do one more thing, that is the load combination. So to create load combination, you have to click on comments, then click on loading, then you have to select load combination. So here you have to select automatic load combination, so that the automatic load combination will be created. Here first you have to select the Indian code, and here just click on this generate load. So here you can see the all the load combination as per IS 456 and IS 1893 automatically created. So now just click on add, then close, then you can see all the load combination is automatically created here. And now this file is ready to run. So before run this file, one more command I have to add. So just you have to go this command menu, then you have to click on this analysis, then you have to select perform analysis, then here select no print, then click on OK. So just see the editor page here, another command is added, that is called perform analysis. Without this command you will see some error here. So now this file is ready to run. So now I'm going to click on this analyze, then run analysis, and here you can see the STAAD is running this file, and now the analysis is completed. Now the analysis have done. Now I'm going to see the result here. Now I'm going to show how to see the analysis report. So to see the analysis result, click on this post processing tab, and here in this result setup, first of all you have to select load cases. So here by default this envelope is selected. So if you select these, what will happen, the here all the load case you can select for envelope. I mean, among these load cases, which one is the critical load case, it will automatically calculate that. And in range, here it is selected all. It's been here whatever result I will get, that for all member, but I don't want to get the result of all member. So first I want to see what is the result for group 1. The group 1 was the beam member along x direction up to 3rd floor. So here we can get all the necessary data like node forces, beam forces, animation, and also we can generate report here also. So I'm just showing which data is actually necessary for designing the member. So here I will only cover those part. So first here I'm going to click on this beam tab, and under this beam tab you can see there are total 3 tabs. So here sometimes we need the stress data. So if you click on that tab, here you will see all the stress result for you can for different member. And if you click on this force data, here you will get all the forces value like bending moment, shear force, deflection, all. Here you can see the bending moment diagram for load case 1, and also you can get the bending moment diagram for load case 2, for dead load. All the necessary data here you can see. And in this table you can see this is the beam end force table for G1 group beam, and this is the beam force details for G1 group beam. So whatever data it is required for you, you can get all type of data. Or if you right click on this table, here also other tables are available like node displacement table, beam end displacement table. So all type of tables, displacement force tables are available here. So which data is required for you, you can easily get that data from here. So for our design purpose, I will generally take this beam forces details data. So here you can see different tab. Here if you click all, you'll get all the forces value here. And if you click on that maximum axial forces, here you will get only the maximum axial forces value. If you click here maximum bending moment, you will get the maximum bending moment data. So there are different tabs also there. So but I'm going to click on here all, because I need all the data here. And here you can see the distance. I mean, see here, here you can see the beam ID, then here you can see the load cases, then this is the distance, this is the fx, fy, fz and mx, my, fz value. So here this distance mean this is the distance at where we are considering the section. So here we have considered the interval is 0.4 meter. This interval can be increased or decreased. So if we take many number of section, so obviously many number of data will be available and we can increase the accuracy. So if you want to change this interval, just click on this result setup, and here under this range tab, here you have to change this value. Suppose I am making it 5, then here you can see the interval is changed. Now we are getting at 0.8 interval. So like that we can change the interval. So if we take many number of section, so we'll get the more accurate result. And now you can copy these values in Excel sheet. So to copy the Excel sheet, first you have to select this. To select this, just click on here, and here you can see all the table is selected. Now just press Ctrl C and now open Excel spreadsheet, and now paste here Ctrl V, and here you can see all this value is copied in Excel sheet. And now easily you can find out what is the maximum mz value. So what we have to do, we have to calculate two mz value. One is positive bending moment and second one is negative bending moment. So that's why what we have to do, positive moment, and then we are going to calculate negative moment. And now here just you can write the formula like equal to maximum close this bracket, and now here we're getting maximum positive value this, and now right just here minimum, then we'll get the negative moment here. So we're getting maximum positive moment and we're getting maximum negative moment value. So this is the maximum and minimum positive moment we are getting from this table. And also by using Excel formula you can calculate which load is the critical load. So this is how you can find out the maximum and minimum bending moment value, and also you can calculate the maximum bending moment, maximum and minimum shear force value for design. So once you get this maximum minimum bending moment value and you get the maximum minimum shear force value, then you can easily design the beam manually. So either you can use this beam, either you can design this beam using this data, or you can also design the elements here in STAAD Pro software also. So that part I have covered in the next video. So this is how you can get the analysis result. And here you can see the bending moment diagram. If you want to see the value, then click on this view value and select which value you want to display. And if you want to change the scale, and that you can change the scale, like here you can see the bending moment about z-axis. So if you change the scale, automatically this value will be increase or decrease. So this is how you can get the bending moment and shear force diagram for each and every member for all the load cases, and also you can find out the bending moment and shear force diagram for infill of also. So this is how you can analysis a G+6 Storey building and get the analysis result. So thank you for watching. If you like this video, share it with others and subscribe my channel.